Rahim. Assalamu alaikum, dear students. This is our next problem. As usual, till now we are following the book Modern Physics by Kenneth S. Crane. Okay. From this video or problem, we are going to start line spectra of hydrogen atom. Okay, spectra is plural of spectrum. Spectra, line spectra of hydrogen atom. Okay, here lines are equivalent to or correspond to wavelengths. Okay, so anyhow, we first come to its statement. Okay, the shortest wavelength of the hydrogen Lyman series is 91.13 nanometer. Nano meaning 10 to power minus 9. Okay, find the three longest wavelengths in this series. Series means Lyman series. Okay, the shortest wavelength of the hydrogen Lyman series is 91.13 nanometer. Find the three longest wavelengths in this series. Now we move to its solution, but before solution we will discuss helping tools. Okay, for the purpose of solving this problem, only one helping tool has been selected or chosen, and there are about two versions. Yes, there are two versions of this helping tool. Okay, even if we do not discuss this helping tool, even then our problem will work, because actually, dear students, the nutshell of this helping tool, that is the helping tool number one, which has been presented in two versions. The nutshell of this tool has been included in our solution. Okay, I first move to that part. Okay, this is our beginning part of solution, and this thing, that is this statement from we know that two respectively. Okay, this portion includes all the philosophy contained in our tool number one, which has been presented in two different versions. Okay, moreover, it is important to point out that this wording, that is from this we know that two respectively, will be repeated many times in our next many problems. Okay, because this is a combined situation which deals with Lyman series, Balmer series, Peston series, Brackett series, and Puffund series. Okay, I think this in this word, that is PFUND, one letter may be silent. If we assume P as silent, then it should be read as a fund series. If we assume F as silent, then it will be treated as a fund series. But we assume that nothing is silent. Okay, because exactness of pronunciation is not our primary concern. Okay, So dear students, because this wording, that is we know that from this to this respectively is actually a foundation for a large number of problems. Some of these problems may belong to Lyman series, some may belong to Balmer series, some may belong to Question series, some may belong to Bracket series, and some may belong to Profound series. But in all cases, we will repeat this wording, that is from this we know that to respectively. Okay, anyhow, we come to our helping tool, and as a formality we see what it says. Okay, tool number 1 says Balmer 1 over lambda is equal to r 1 over 2 square minus 1 over n square, where n is equal to 3, 4, 5. The quantity r known as Rydberg constant. Okay, Rydberg or Rydberg, I am not very much clear. Okay, Rydberg or Rydberg constant. The quantity r known as Rydberg or Rydberg constant has the value r equal to 1.097 into 10 to power 7 meter inverse per meter, which alternatively becomes equal to 0.01097 nanometer inverse. This is Rydberg or Rydberg constant. Okay, now we move to Lyman series. Lyman series 1 over lambda equal to r 1 over 1 square minus 1 over n square, where n is equal to 2, 3, 4 and so on. Dear students, here we had seen that when this is 2, then n starts from 3. Okay, that is one step ahead. Now when this is 1, then n starts from 2. Okay, that is one step ahead. Okay, so actually Balmer and Lyman, these two series come within one framework. That is why remaining 3 series have been separately discussed. Okay, in the infrared, 3 spectral series have been found whose lines have the wavelengths specified by the formulas. Question: 1 over lambda is equal to r 1 over 3 square minus 1 over n square, where n is equal to 4, 5, 6. Okay, the same pattern is going on, that the number which comes here, n begins with one step ahead next to this. Okay, in case of bracket, 1 over lambda is equal to r 1 over 4 square minus 1 over n square, while n starts from 5. Okay, so fund or pund. Okay, 1 over lambda is equal to r 1 over 5 square minus 1 over n square, and n is equal to, n starts from 6, that is one step ahead or one step advance than this number. Okay, so what pattern comes before us, that when there is 2, n starts from one step ahead, that is 3. When this is 1, n starts from one step ahead, that is from 2. When this is 3, n starts from one step ahead, that is from 4. When this is 4, n starts from one step ahead, that is from 5. When this is 5, then n starts from 6, that is one step ahead or one step advance than this number. Okay, now we come to its alternate versions. Some spectral series for the hydrogen atom: Lyman series, ultraviolet. Okay, nf is equal to 1, ni is equal to 2, 3, 4. Okay, when 1, then this begins from 2. Balmer series, visible ultraviolet, nf is equal to 2, then ni starts from 3, one step ahead. Paston series infrared NF is equal to 3, then NI begins from 4, that is one step ahead. Bracket series infrared, that is NF is equal to 4, NI starts from 5, that is one step ahead or one step advanced than this. Fund series or fund series or fund series infrared NF is equal to 5 and NI starts from 6, that is one step ahead. Okay, the same pattern, the same thing has been repeated here in a slightly different pattern or method of expression. Okay, anyhow, now we move to our solution, because nutshell of tool number 1 has been included in our solution, this thing which starts from, we know that, and ends at respectively. Okay, when we will read this, we will come to conclude that this is exactly same what we have dealt with in tool number 1. Okay, we know that lambda is equal to lambda limit n square over n square minus n naught square, where n is equal to n naught plus 1, n naught plus 2, n naught plus 3 and so on. This is equation number 1, where lambda limit is the wavelength of the appropriate series limit, while n naught equal to 1, 2, 3, 4 and 5 for Lyman, Balmer, Peskin, bracket and Pfund series respectively. Okay, what is meant? Meaning that for Lyman, n naught is equal to 1, and when n naught is equal to 1, then n starts from 2. Okay, for Balmer, n naught is equal to 2 and n starts from 3. When for Peston, n naught is equal to 3 and n starts from 4. For bracket, n naught is equal to 4 and n starts from 5. Okay, and for Pfund or fund series, n naught is equal to 5 and n starts from 6. Okay, respectively. Nothing new. We have just reshaped the philosophy contained in tool number 1 according to our ease or according to our understanding. Okay, now dear students, using n naught equal to 1 and n equal to 2, 3, 4 and lambda limit equal to 91.13 nanometer in equation number 1, because this thing is given in the statement, and in the statement one more thing is given. What thing is given? Yes, Lyman series. Okay, one thing is given, that it is Lyman series. Lyman is given and 91.13 is given. Okay, these two things are given and remaining things we have to find out. Okay, so matter is simple, not any confusion. Okay, solution, we have dealt with this. Now using n naught equal to 1, because we know that for Lyman series n naught is equal to 1 and n always starts one step ahead or one step advanced than n naught, because n is equal to n naught plus 1 and lambda limit is given in the statement. So these two values we will put in equation number 1. So in other words, in equation number 1 we are not putting 2 things, we are putting 3 things, because n is associated with n naught. So we also know the value of n naught, and we know the value of n, and we know the value of delta limit. Okay, so we are putting three things in equation number 1. Okay, so equation number 1 says that lambda is equal to lambda limit into this over this, out of this one is n and one is n naught plus here n naught is 1 and n is 2. Okay, quite clear, simple, because this is a Lyman series. Lambda limit is given. Moreover, for Lyman series, n naught is equal to 1 and n starts from 2. Okay, so first time we will put n equal to 2, second time we will put n equal to 3, and then we will put n equal to 4, and we will find these three values. Okay, in other words, we will put first time n naught equal to, n naught will be 1 always. Okay, anyhow, lambda is equal to this. Here in place of n we have used 2, n square over n square minus n naught square. In place of n naught we have used 1. So 4 over 4 minus 1 becomes 4 over 3. Lambda is equal to so many nanometer into 4 by 3. This implies that this 3 will be multiplied with lambda, and we will get 3 lambda equal to 364.52 nanometer. Okay, what is how this figure has come? 4 has been multiplied with this, and so 99 4 times 91 is almost equal to this 364. Okay, so when 3 lambda is equal to this, then 1 lambda will be equal to this divided by 3. So lambda becomes equal to 121.51 nanometer. Okay, next, again we are using the same equation number 1, and here what we are doing, n naught is same 1, but n in previous case we had used n equal to 2, but here we are using n equal to 3. Okay, similarly in the next case we will use n equal to 4. So lambda becomes equal to this into 9 over 9 minus 1, meaning 9 over 8. This 8 will be multiplied with this, and it will become 8 lambda equal to this. Okay, when 91 will be multiplied with 9, then it will become about 820. Okay, so 8 lambda becomes equal to this 820 plus 17 nanometer. So 1 lambda will become equal to this divided by 8, and hence lambda will be equal to 102.52 nanometer. Next, lambda equal to this and 4 square over 4 square minus 1 square. Okay, as I have said earlier that n naught will always remain 1, but n will be increased from 2, 3, 4 and 5, 6, 7, but we are asked to get 3 values, 3 wavelengths, 3 lines. Okay, so this will become lambda equal to this into 4 square 16, and here 4 square again 16, 16 minus 1 15. So 16 over 15, here 15 will be multiplied with this, and so 15 lambda will become equal to this, that is 91.13. when multiplied with 16 will become equal to this. Okay, so when 15 lambda is equal to this, then 1 lambda will be equal to this divided by 15, and hence lambda becomes equal to 97.21 nanometer. And this is the end of our problem, our solution. What we have found, we have found first value this 121.51 nanometer, second value 102.52 nanometer, and third value 97.21 nanometer. And this is the end of our problem. And this is the end of our video, and till next video, Allah Hafiz. Okay.